Hello, ladies and gentlemen. Today I would like to tell you about evaluation of the effectiveness of the used polymer-based solution to reduce the dust load on open pit mining sites. Atmospheric dust pollution of mining technogenic objects has a complex and long-lasting negative impact on environment. To prevent it, physical and chemical stabilization of dusty surface should be carried out. In this article, we experimentally studied the effectiveness of using polymer composition to reduce the dust load on the example of dust samples from the Lumivara granite quarry. Lumivara is located in the Republic of Karelia, 1.5 kilometers southeast of Ikhala. The quarry is producing building stone. At all stages of quarry development, a large amount of inorganic dust is released into the atmosphere. Such dust, with a silicon dioxide content of 20 to 70%, belongs to hazard class 3, and its particles of less than 10 microns in size pose a serious threat to human health. The atmospheric monitoring of the dust content conducted in the last fall revealed the need to use additional means to reduce dusting. Near the storage of dropouts and on the internal roads, a significant excess of the maximum permissible concentration was detected by several dozen times. At the border of the sanitary protection zone, the maximal permissible concentration was exceeded in more than half of the monitoring points. Dust samples were collected from 3 different sections of the quarry, from the crushing and screening plant, internal roads, and the drop-off dam. Granulometric analysis of these samples was performed in the Mining University laboratory using the Hariba LA laser particle size analyzer. A special experiment installation was designed at the Department of Geoecology. The installation includes a dust suppression hopper into which air is pumped to simulate the movement of air masses. The level of dustness is determined using the dust analyzer of the atmospheric monitoring dust track. During the experiments, the dust weight of 10 grams was evenly distributed over the area located in the center of the hopper. The test solution was applied to it, and the hopper was hermetically sealed. In parallel with the air supply, the dust analyzer was put into operation. The duration of each experiment is 60 minutes. The total dust concentration is recorded every second. Dusting of dry samples begins immediately after the air supply, and the values of the dust concentration reach 150 milligrams per cubic meters. Using water, in the first 10 minutes, the dust concentration in the hopper is about 4 milligrams. However, the water quickly evaporates and the dusting intensity increases several times, almost reaching the indicators of loose samples. That indicates inefficiency. To reduce water consumption and increase the efficiency of dust suppression, we used a water dispersion of polyvinyl acetate. The polymer is absolutely safe, non-toxic, and has a good adhesion properties to natural materials. To determine the optimal concentration of polyvinyl acetate, 3 experimental variants were carried out: 600% water dispersion, 1200% and 2400%. The dust suppression efficiency reaches a maximum at a concentration of 1200% and then changed slightly. The addition of polyethylene glycol changed the dusting dynamic of the samples. The addition of polyethylene glycol resulted in better dust retention in the initial stage of the experiments due to its prolonged drying. As a result of the experiments, it's found that the use of 1200% polyvinyl acetate solution leads to a decrease in the concentration of dust in the air by 3 times, and 24 100% polyvinyl acetate solution by 3.5 times compared to the use of the same amount of water. The use of mixture of these components in low concentration change only the dusting dynamic of the samples, while the average dust concentration during the experiment remain at the same level. The mixture shows the best result in a short period, and the water dispersion of polyvinyl acetate is well suited for long-term dust suppression. That's all, and thank you for your attention.